Hello, this is Group 8 presenting the auditory pathway. The content slide is a brief visual of the concepts that will be gone over during the presentation. The first structure to get us started on the auditory pathway is the outer ear. The outer ear is made up of two main structures, the pinna and the ear canal. The pinna has 10 landmarks that make up the grooves and ridges on the structure. The outer one-third of the ear canal is made of cartilage consisting of hairs and glands. The inner two-thirds is bony and has a thin layer of skin. The two structures are responsible for funneling in sound as well as having unique functions of their own to help us process the direction and loudness of different sounds. Due to the pinna's different landmarks, the grooves and ridges help create monaural and binaural localization cues that help us tell the difference between sounds as well as the directions they are coming from. The ear canal has the natural function to act as a resonating chamber that helps intensify the amplitude of incoming sounds. And thanks to the ear canal's narrow and curvy structure, it helps protect the tympanic membrane from any type of physical damage. The hair and glands found in the ear canal help trap dust and create cerumen that acts as lubrication for the skin.
We have three major structures of the middle ear includes first we have the tympanic membrane. We can also call that TM. It plays in a way that it separates the middle ear from the outer ears. Landmarks of the TM include the placida, placentia, and ompos, and the cone of the light. The second one we have that the eustachian tube is the structure that connects the middle ear to the nasal sinus cavities. The third one we have that's the obstacle structure that is marked up by the obstaculum, including the malleus, incus, steps, manubrium, and the step folate. The malleus is connected to the tympanic membrane by the manubrium. The incus is connected to the middle ear by the step folate and the oval window. And leaving the incus as such as the middle connection between the malleus and the steps. And we also have the muscle of the middle ears. The tensor tympanic muscle, they are located within the anterior wall of the middle ear, and each tendon is attached to the meatus. The tamias muscle is located within the posterior wall of the middle ear, and each tendon is attached to the state. And we have the picture of tympanic membrane, the occipital and the middle ear muscle, and the eustachian tube. Next, we will do the middle ear physiology. Physiology of the tympanic membrane, occipital, and muscle of the middle ears. The functions of the tympanic membranes and the ossicles is the transmission of the sounds from the outer ear to the inner ears. The tympanic membranes rhythm variations and those variations are transferred along the occipital into the inner ears. The air of the middle ear is less dense than the fluid of the inner ear, causing a loss of pressure about 36 dB. This loss of energy is caused by three mechanisms. The buckling effect causes to be transmitted from the center of the tympanic membrane rather than a loss of whole membrane. And that of the TM is 17 times rather than the step folate attached to the oval window. The difference is in surface because of the proportional in ratio from the TM to the step. The malleus is longer than the incus, causing a level effect in resting ratio by 1.15 times the tree's mechanisms in rest ratio by about 32 dB. The function of the tensor tympani and the stapes is the release ratio transmission through the middle ears. When the tensor tympani contract, it pulls the malleus tensors. The TM reducing ratio transferred. When the tap contracts, it pulls the step from the oval window, reducing ratio transfers. We have physiology of the eustachian tube. The functions of the eustachian tube at equalizing ratio at pathway and rotation. Muscle contractions can a small opening in the eustachian tube allowing for air to move into or out of the middle ear equalizing ratio. Allow the up fluid from the middle ear to the nasal sinus cavities. In the eustachian tube, it normal close maintaining up the between the brow and the middle ear chance of reduce the chance of the infection.
Inner ear anatomy. Semicircular canals. The anatomy of the semicircular canals are three small circular tubes, liquid-filled, and they're all connected to the vestibular nerve, which is located in the inner ear. The three canals are the superior canal, the posterior canal, and the horizontal canal. Number 2, the vestibular organ. This organ is a sensory system that bodies the semicircular canals, the cochlea, and the auditory nerve that all connect to for each ear. This organ is also located medially and is next to the temporal bone and the oval window and round window in this organ. Number 3, the auditory nerve. This nerve is located behind the cochlea. It can also be called the cochlear nerve. It merges into the vestibular nerve so they combine to make the 8th cranial nerve. More of the inner ear anatomy. Number 4, the vestibular nerve. This nerve is posterior to the auditory nerve. The vestibular nerve is connected to the vestibular system near the utricle and saccule. Number 5, the 8th cranial nerve, the vestibular cochlear nerve. This is the cochlear nerve and connects with the vestibular nerve. Number 6, the cochlea. Coiled-shaped fluid-filled structure and is the size of a pea. When the cochlea is uncoiled, the superior portion is the scala vestibuli, which is separated via Resner's membrane. Below lies the scala media. The tectoral membrane is within the scala media, and below is the organ of Corti, which contains hair cells. There are 12,500 outer hair cells, which consist of 3 to 5 rows, and 3,500 inner hair cells, which consist of 1 row. The reticular laminae is a protective barrier before the start of the stereocilia above the hair cell. Anterior to the organ of Corti lies the basilar membrane, which separates the scala media and the scala tympani. Here are some images of the inner ear anatomy. The first one shows the vestibular nerve, the vestibular cochlear nerve, and the cochlear nerve. The second image that is shown is the vestibular organ, the semicircular canals, and the cochlea. Inner ear physiology. The cochlea houses auditory and vestibular organs. When the stapes pushes on the oval window, the movement causes movement in the fluid-filled portion of the cochlea that forms a traveling wave. The basilar membrane moves up and down based on the frequency of the sound. The base of the basilar membrane moves as low as 20 to 25 Hz, and the apex of the basilar membrane can pick up on 1,600 Hz. Outer hair cells. Outer hair cells are efferent pathways from brain to hair cells. The outer hair cells' function is to protect the ear from loud noises or block out white noise. Inner hair cells. These hair cells are afferent pathways from hair cell to brain. This occurs when stereociliar tip links press against the TM and positively charges the ions that enter hair cells. The inner hair cells send auditory signals to the eighth cranial nerve, which sends auditory information to the brain. Here's some more inner ear physiology. The vestibular organ. This organ system, which contains the utricle, which it is responsible for all movements on the horizontal plane. The saccule is responsible to detect movement on the vertical plane. The semicircular canals detect rotation movements of the head from the hair cells within these canals. The posterior canal is ear to ear, the lateral canal is the vertical axis, and the superior canal is the lateral axis. The auditory nerve and the eighth cranial nerve. The purpose of the auditory nerve is to send information to the brain from the sound waves we hear from outer sources, and the eighth cranial nerve is responsible for sending the signals from the auditory nerve and the vestibular together to then form a signal to the brain and then process what we hear and help us with our balance.
I will be talking about the central auditory nervous system, the CANS, as the afferent pathways from the cochlea to the brainstem. There are 6 steps between the cochlea and the brain, which ipsilateral auditory information is processed via hair cells and reaches the cochlear nucleus, which differentiates monoaural localization cues. The information is then processed contralaterally and binaurally localized by the superior olivary cortex and differentiates intensity and arrival time between ears. Then information reaches the lateral lemniscus. The next brain pathway entered is the inferior colliculus. Then the auditory information reaches the medial geniculate body. Lastly, the information is stored and processed via the primary auditory cortex. The primary auditory cortex is located in the temporal lobe of the brain. I picked 2 images to show this as the sound enters the brain stem. And I think what's important to note is once the auditory information reaches the superior olivary cortex, it is binaurally localized. And then we have our bibliography slides. And that is it. Thank you so much for listening and have a great rest of your day.